All right, so you guys know in the past we've been dealing with graphing. We're going to move away from graphing over these next couple of weeks. And we're going to start really this unit. We're going to dive into exponents, the different types of exponents, and the different forms of how they can be written, combining them, multiplying them, dividing them. It's basically a whole unit of specifics about exponents. Okay, so the first thing that we're going to look here, guys, is monomials and what they are. You guys have some experience with monomials. Any of you guys ever heard the term monomial before?
I have.
Some of you may have. What about polynomial?
I've heard that.
That's a little more familiar. What does the prefix mono mean? One. Okay, so that's going to be what we're focusing on, guys. So a monomial is a number, a variable, or a product of a number and a variable. Okay? Now, examples of monomials, guys, I'm going to give y'all some examples. Now, again, these are examples. These are not limited to do just what I give you. An example of a monomial would be 5. It also could be 5x. It also could just be x. Okay, like it talks about in the first two things, what monomials are, guys. It could be a number, it could be a variable, or it could be basically a combination of all of those things. Okay, we can even say that it could be 5x. Now, I'm going to hit this little exponent button right up here. When you guys are typing, your toolbar should pull up. It's x to the 2, and I'm just going to put a 2 exponent with that. I'm going to square it. Okay, that is a possibility. The exponent could be 3 or 4 or 5 or any number that you wanted to put with that exponent. Okay, but again, these are just examples. When you want to remove it, you just uncheck it. Okay, it also could be something similar along of 5xy. Does it have to be an individual variable? You can have multiple ones. As long as they're grouped together, monomial, one piece, one whole, one term right there, okay? I guess really term would not be the word, but one grouping, okay? It could also be 5x. You could put an exponent with those, like 5x squared and y squared, or y to the third. Okay, any of those are possible options. Zoom in a little more for you guys. Okay, still dealing with some options here. We could also have fractions. Okay, you could say 5/11, okay? Or it could be a half, a third, a fourth, a fifth, any of those, okay? You could also say 5/11 x, okay? You could go 5/11 x with an exponent. Okay? Again, this is not just limited to what we have here. Those 5s could interchange with any number. Those x's could interchange with any variable. Your exponents could change with any variable. It also could include decimals as well. But you guys know fractions are just another way to write a decimal. Okay? Are y'all good there? All right, so we're going to look at monomials. Okay? But these monomials have the same variables and exponents. Please emphasize, guys, same goes with variables and same goes with exponents. Okay? So when you have things that are the same, specifically monomials, what we're talking about here, guys, what is it that you call those things that are the same, that are like? They are like terms. Okay? Which we've talked about the second week of school. Okay? So monomials that have the same variable and the same exponent. Not some that are similar, not some that are close, but it must be the same variable and the same exponents. Those are like terms. Okay? What you guys are familiar with? To add and subtract monomials is where we're moving to from here. Okay? You must combine like terms. Now you can space those out and put them in the blanks, or you can just write it out. Okay? So adding and subtracting monomials, guys, it's just like what you already know. If they are alike, you combine like terms. Okay? Can you combine a 5x with a 2x? Yeah. Can you combine a 5x with a 9y? No, because they're not alike. Okay? But you guys are familiar with that. The biggest thing that you need to remember, do not change the variables and the exponents. Okay? We're just combining what I call our base number or our coefficient. Okay? All right, so if we're looking at number 1 here, guys, my base number or my coefficient is 17. Okay? We have an x and x. My variables are the same. So what would you call 17x and 25x? You would call those what? Like terms. Okay? So if they're like terms, we can combine them, whether it's adding or subtracting them. Okay? So if you have 17 x's and you take away 25 of those, it'd be negative 8 what? X. Okay? Pretty simple. Now, we're going to work down on the left-hand side of the column here. So we're going to go straight down to 13. Okay? All right, my coefficient or my base number is negative 15 and 6. Now, we've got several different variables here that we're looking at. We've got A, B, and C. Do both monomials have those on them? Yeah. Okay. They also have a what? An exponent. So on the first monomial that we're looking at is 3, or excuse me, the first monomial we're looking at has an exponent of 3. That 3 is with what variable? A. Is it with the same one on the second one? Yeah. Are these just alike outside of our coefficient or our base number? So can we combine these like terms? All right. So we got negative 15, and then the rest of that combined with that 6. So negative 15 and 6 is going to be what? Negative 9. And we have A. Remember, you can go right up here. Use that little exponent button. I think that's a new tool with Cami. So 2. Excuse me, not 2. 3. Uncheck it. And then we have BC. Okay? All right, looking at 5. We've got 2AB plus 9AC. Looking at these two monomials, are they like terms? No, they're not. They're not exactly alike. So we will end up, when we simplify these, it's going to be 2AB plus what? 9AC. We leave them just like they are. That's simple. If they're not alike, you can't combine them. All right, 7. You got 2/5 CD squared minus 1/3 CD squared. Do we have like terms here? Can you combine them? All right. So what is 2/5 minus 1/3? All right. So yes, that is 1. Excuse me, 15th, and CD squared. Y'all good there? All right, here. Number 9, we got 3y, 9z plus 4y minus 3z. Okay? We've got several monomials here. We have 4. But what can you combine with the 3y? 4y. So 3y and 4y is going to give you 7y. And then 9z minus the 3z is going to give you, is that plus 6z or minus? Plus. Okay? All right. Trick question, how do you know if it's plus or minus? If the number's what? Positive or negative. Okay? All right. All right, looking at 13. Now, don't get confused with 13, guys. They must be like terms. Now, do they all have the same variable? Yeah. Okay? But do they all have the same exponent? No. So you can't combine them all. All right, so looking at 13w squared, what can you combine with that? The 4w squared. So 13w squared plus 4w squared is going to give you 17w squared. All right. And then we have 9w minus 31w. It's going to give you what? Negative 22w. Okay? All right. Now, 13 and 15, it says find the sum. All that's doing is telling you to do what? Add. 15, it's telling you to do what? Subtract. Okay? 14, difference means no. Difference means what? Subtract. Okay? Because we have not talked about any multiplication division. The only operations that we've dealt with adding and subtracting monomials is adding and subtracting. Okay? And then 16, it tells you to do what? Subtract. Okay? All right.